So, hello, welcome to the presentation Unity Defense, how security analysts, developers, and data scientists collaborate on machine learning-powered phishing detection. Let me introduce our speakers. Ilektra Giassa, our data scientist, and me, Pavel Krčma, head of Network Detection Group. In this presentation, we will show you how Jamf Threat Labs and our researchers work with data scientists to improve phishing protection. Basically, we split this complex problem to detect phishing between our analysts who understand the threat landscape and data scientists equipped with machine learning knowledge. Two teams, one project, and let's dive in. Key statistics from our Security 360 annual trends report. Numbers are platform agnostics and cover both mobile and desktop platforms. 10 million is the approximate number of phishing attacks identified by Jamf in the past year. In the same time, Threat Labs classifies 10 million unique resources every year. Not all attacks are unique and not all resources are malicious, but this number demonstrates the volume of data we process. Also, 1/4 of organizations experienced a social engineering attack. In the same time, 1 in 10 users clicks on malicious link. Those numbers indicate that all of us have a very high chance of being victims of phishing attacks. More than 90% of cyber attacks start with phishing. So, in combination with previous numbers, it's pretty clear that phishing is a very powerful way how to infiltrate an organization. Attackers are using automation, social engineering, global infrastructure, and recently also AI-powered tools. Attackers leverage legitimate service providers, for example, Firebase, to host phishing web page that mimic legitimate services. The average lifespan of phishing page is relatively short, often measured in hours rather than days, with many lasting less than a day. So we need some complex method how to detect this type of attacks. Let me show you a real-life example. This is a web page of phishing against British Telecom. The goal of this page is data collection. It uses WebSockets in the background to collect every single stroke you put on this website. So even if the victim realizes in the middle of the attack that he's on the wrong page, all data are already sent to an attacker. In the bottom, you can see the download button. This button installs web application in order to push more spam using browser notifications. You can maybe also see the incorrect spelling of the word password the attacker is using two single U letters instead of W. Attackers trick security tools that scan for suspicious keywords, causing them to miss these obfuscated strings. Other approach is to use Unicode obfuscation. Unicode obfuscation works by replacing standard characters with visually similar Unicode counterparts. So, for example, A can be represented in Unicode alphabet by many different forms, which are very hard to spot by naked eye. In order to fight with modern phishing, we cooperate with data science on better detection technique. And to do that, we split the work. Analysis and data processing goes to Threat Labs. Machine learning goes to data science. And network analysis pipeline is the point where we connect all those parts together. In the center is the database, where we store all findings, all IOCs, basically all data we analyze. This database is fed by workers we call feeders. The role of feeders is to get all data we know from outside world, both private and public feeds, and pass them through filters to the database. Filters decide which type of analysis will be used on top of this particular network resource. One important type of analysis is Sibling generator. Sibling generator is the point where we try to identify other similar resources to the one being analyzed. So for example, we check other sites hosted on the same IP address, other domains sharing similar characteristic of registration, and so on. Also, we use customer impact analyzer. Customer impact analyzer gives us the information how many customers hit this particular resource. And this analysis is used as kind of safety brake against some nasty false positives. So in case that we are about to block some resource with high customer impact, we double check what is it, if we can do that, and so on. Another important source of data is website collector. It is a set of scrapers which scrape data from interesting websites. We collect raw content of websites, including screenshots, and use them for training of machine learning models. And last but not least, there is a model gateway. This component is the connection to the models. So in case that we need the scoring for a particular resource, we ask the model gateway and get the scoring we can process later. And network analysis pipeline processes about 10 million resources every year. During data acquisition, we face multiple challenges. First, balanced dataset. Balanced dataset means that we need the similar amount of clean and dirty data for all type of data we use for model training. Without balanced dataset, model doesn't provide correct results, so it's balanced to one or other side. And current environment creates a lot of challenges to get, for example, data in a lot of different languages and a lot of different type of web pages. So for example, we fight with Cloudflare protection, CAPTCHA, IP blocking, user agent detection, basically anything what is in current internet available, and especially in addition to AI scrapers, which basically do the same. Other challenges are clean data really clean, and are dirty data representative enough? Incorrect data in dataset is like a drop of poison in the glass of water. So even the small amount of clean data in dirty data set and vice versa means that the model doesn't provide correct results. And next step for our analyst is to define phishing indicators, also called features in data science. A feature in machine learning refers to an individual measurable characteristic or property of an object that is being observed. In other words, is the way how we identify that one particular resource is more likely clean or more likely malicious. Data labeling is crucial for machine learning because it provides the ground truth that allows models to learn patterns and make accurate predictions. Without proper labels, machine learning models struggle to understand and generalize from data, leading to unreliable results. So, manual work here is very important. So we built our internal portal for labeling, which makes life of our analysts much more easier. Currently, we classified about 50 resources every year, which sounds like small amount of data, but they are high quality data used in machine learning model training. So later on, we can classify much more higher volume of similar characteristics and similar resources. So now we have all data prepared on this point, and it's time to explain the data science part. I pass the word to Ilektra.
Thank you, Pavel, for the nice introduction. So our collaboration is based on two pillars. On one hand, we have the Threat Labs team. They are the experts they hold all the domain knowledge that we leverage. They perform the data collection utilizing the network resource pipeline, and they also perform the threat analysis with a variety of methods. On the other hand, we have the data science. We are responsible for the data analysis, the feature extraction, and also the development of machine learning techniques that are actually scalable. As Pavel presented previously, we are talking about a volume of tens of millions of network resources that are being analyzed. Of course, this manual work is extremely strenuous. So the landscape of phishing is definitely not stationary. So phishing detection methods that were very successful a couple of years ago or a decade ago are extremely outdated. So the traditional approaches were largely based on domain and URL-based heuristics. What happens nowadays is that malicious actors utilize automation and, of course, AI. And this introduces a high degree of complexity. So those traditional approaches, or approaches that are in principle static, are not able to capture the sophistication of the phishing attacks. So what we do in data science to address that? So we develop two distinctly different, but at the same time complementary approaches. So the first one is a so-called statistical approach. So this approach utilizes the phishing indicators that Pavel talked about previously. So from those phishing indicators that are extracted either from the literature or from the Threat Labs team, and of course they're actually assessed by the data science, we can engineer features that come directly from the HTML content of the network resources that are being collected by the Threat Labs team. On the other hand, we have the so-called TF-IDF approach. So I have a question for you. Do you know, or have you heard, or even used before this presentation, TF-IDF? No one? Okay, I'm glad. I can talk a bit more then. So the TF-IDF approach is quite different, and I will explain a bit more later. So here, the feature derivation actually reflects how important a word or a phrase is to the collected HTML data. So we have a corpus, and TF-IDF is able to highlight which phrases are most important. I will explain a bit more later. So let's see a bit more what the statistical approach does. So from the literature and also from the discussions and collaboration with the threat analysts, we were able to extract some features that are actually relevant and provide information gain and help with the performance of our models. So here is a very short list of those features. One of those is the existence of forms with external links. So for example, here we have a link that can potentially lead to a phishing website. Another feature is the existence of spelling errors. So previously, Pavel presented a form that actually had a spelling error. It was password instead of password. So in principle, that indicates that the creator of this network resource did not really pay much attention. So usually, people who are legitimate creators put a bit more effort. They invest into the content of the page, right? Another such feature is the existence of iframe redirections. So again, we might have a redirection to a phishing website. So in general, the statistical features are either numerical or Boolean. Okay, let's move on to the mysterious TF-IDF. So TF-IDF stands for term frequency, inverse document frequency. So we are just talking about frequencies of phrases. So in our use case, our phrases consist of 2 words. We call them bigrams. So we have 2 terms. We have the term frequency, which is actually the frequency in which a specific bigram appears in a specific document. On the other hand, we have the inverse document frequency, which is the ratio of documents that contain this specific bigram. So as I mentioned previously, TF-IDF, because exactly it's based on relative frequencies, gives us a measure of how important this bigram is to a document. But this is also adjusted for the fact that some words appear more frequently in general. So we have some words, like and, the, and so on, that appear so frequently that they do not really add any information. Okay, so till now, I think you might have spotted already the difference between the TF-IDF and the statistical approach. So on one hand, the statistical approach is looking at the HTML elements mostly, whereas the TF-IDF is looking at the textual content, the visible text, what you see when you open a web page. So TF-IDF is, in general, able to capture the linguistic signatures of phishing campaigns, of course, given that it is trained and kept up to date. So let's move on to a very dummy example. So in this example, we have a really tiny data set. It consists of just 3 data points. So let's say that we have 2 dirty, 2 phishing data points, and 1 clean. So we have click here to reset your password and click here to win a free iPhone. Those are dummy, are very easily, hopefully, you can recognize very easily that those are phishing. So TF-IDF is able to recognize the important bigrams. One step that I'm going to elaborate in a while is that before creating the possible bigrams and identifying them as most important or less important, it removes the fluff. So all those words that appear too frequently to be important. So for example, here to your, those are removed. So the important bigrams in this very dumb example are presented here. And also for the clean data point, your account password has been updated, we have different bigrams. So this is on very high level how TF-IDF is able to produce bigrams that are distinct between the clean and dirty data sets. But let's go one level up. So here we're going to talk about the TF-IDF vectorization. So vectorization in general is the mapping from an object that a model cannot understand to something that a model can understand and is actually a vector. So the process of TF-IDF starts with our collection of text documents. Let's call it HTML corpus. So those are the HTML pages that Threat Labs team collects. So once we have this corpus, we remove all those fluff words, the stop words, and then we tokenize. So at this step, we actually produce all the possible bigrams. After that, we calculate per document the term frequency and inverse document frequency. Then we multiply those two, and we end up with the TF-IDF vectors. Okay. So let's go back to the dummy example. So here we have the exact same data points. And if we do this, again, very dummy TF-IDF preprocessing, we end up with 7 possible bigrams that are represented in the table that you see. So we have 7 possible bigrams in the whole corpus. That means that each of the documents in this corpus can be represented as in a 7-dimensional space. So each vector should have dimension 7. So we calculate the TF times IDF for each document. For example, let's start from the first Bigram, account password. So in the first document, we do not see this Bigram at all. So the frequency of this term is 0. Therefore, the TF-IDF is 0, right? I will not go through all the calculations. I think it will be too much. But in any case, after performing this calculation, we get our vectors. And indeed, they should have direct dimension 7, right? OK. So another level up, talking about how these models integrate with the Threat Labs analysis. So Pavel mentioned previously about the Threat Labs model gateway. So indeed, this is responsible for the communication between the network resource pipeline and our deployment of those machine learning models. So every time a threat analyst wants to score a specific network resource, our deployment is called through the model gateway. And then what happens is, first, this specific network resource is retrieved from the location that the Threat Labs team has stored it. Then the pre-processing step happens, and this is model specific. As we saw, those models are in principle very, very different. Then the next step is the feature extraction, which is again model specific. What results from that is fed into the model, and a score is produced. So this score gives us a probability of this specific network resource being phishing. OK. So we have both emphasized that there are newly emerging phishing patterns and that the phishing landscape is ever changing. So we are talking about a race of arms. So the adversaries adopt more and more sophisticated techniques and constantly evolve, and so should we. So to keep our phishing models on top of their game, of course, we perform the regular retrain so that our models can capture the newly emerging phishing patterns. And those newly trained models are evaluated by both the data science team and the threat researchers. At the same time, again, this issue is not really solved. We might need to revisit the phishing indicators. We might need to update our machine learning models so as to provide the best possible detection levels. This might happen in a few months or a few years, and it's definitely up to us to keep monitoring our models and intervening when this is needed. So in data science, we do not just provide some mechanisms for phishing detection. We also believe that the collaboration with the threat analysts, the evaluation of the data quality, and the constant monitoring is what offers the best results. So let's go and hear more about some success stories by Pavel.
OK, thank you, Ilektra. So here is just a small set of unique findings we found in our data sets. Those domains were not detected by anyone in time when we catch them. So just small demonstrations. And the set of domains consists of plenty of fake cryptocurrency sites, sites asking for payment for car. Maybe you already get some SMS message asking you to pay, I don't know, $20, $30 for fast driving. So this is exactly the type of sites which has very short type of life. And rotating very fast, even on a 1 hour basis, but quite effective. So they are asking for your payment details and go on. Another group of sites are fake delivery services. So again, this is something what people expect to get, so asking for personal details, including payment details, because very often the question is, okay, you need to pay some additional fee for delivery. And another big group of sites are sites used for installation of info stealers, both for Windows and macOS platform. So basically those sites serves just as the leading site which install some additional malware, but still the first step is the phishing. So attackers are trying to attract victims by mimicking well-known brands. So not surprisingly, you can see in the list of top phishing brands AT&T, Coinbase, Facebook, Microsoft, plenty of delivery services, something what anyone expect to get on your phone by SMS, by email. So, thank you for attention. You can find us at the Jamf booth in Threat Labs and AI section, and questions. Yep.
In terms of spelling errors, I understand that words like password can be obfuscated, but we still see many other words, like please in your example. Is that a strategy to have so many spelling errors that are visible?
Yeah, it's the way how to obfuscate or how to hide the malicious site from the scanners, because one typical approach is to scan for typical login forms or registration forms or payment forms, which has some defined structure. And also properly built forms use proper HTML tags. But attackers in phishing kits are using not only obfuscation of texts, but also obfuscation of the HTML code. So they are not using proper tagging of input fields and so on. So any scanner which is trying to identify login form, registration form on a particular website could skip this site, because without rendering in browser, it's not clear that this particular form is really something asking for your personal information. So in combination with incorrect spelling, it could fall behind the main focus of scanners. The same with Unicode obfuscation.
Yeah, and if I may add to that, we have found that in the data that is relevant to us, and that's why I present it as a feature of the statistical model, we actually detect such spelling errors and they add to the information gain. So yeah, indeed, it's not uncommon.
Yeah. Yeah.
One thing that's always bothered me with phishing scams through email is that they often are emulating known company. Like it'll look like it's coming from Apple, or it looks like it's coming from a well-known bank or something like that, but clearly not coming from that company's domain. And it seems like it would be such a simple thing to have that analyzed through the system. So it just seems like such a simple thing to analyze the content of the email and compare it with where the domain's coming from to block that. And it's always bothered me why that isn't more easily blocked by some of these systems in place.
That's correct in case you have the visibility into email. But this is something we don't have, because we can't see the content of the email itself. So yeah, that's one approach used by companies who, for example, use a plugin for Outlook or some web extension which can scan the already rendered email in the browser, but this is not our case, unfortunately. So we need to first touch the malicious site, try to identify that, okay, this pretends to be, for example, Facebook or Apple or anything, and the set of legitimate domains is limited. So we can correlate this one. But you are right that this is one approach which is definitely powerful and used in this industry.
Yes?
In those 3 sentence examples for the TF-IDF, I understand the token vectorization piece of it, but where or how does the approach then categorize those vectors as malicious and not?
Oh, yeah, that's a good question. So essentially there is a model, because I just presented the pre-processing part. So after that, the vectors that result from the TF-IDF vectorization are fed into the corresponding model. So the model learns the patterns from those vectors. And of course, the model, the specifics of the architecture can change. So there is always some fine-tuning step there. Does this answer your question? Okay, thank you.
Yep.
First off, fascinating presentation, thank you. Second, this TF-IDF, I find it really curious, and it appears, at least to me, that this could be a tactic that would be usable for like spoken phishing attempts. So if you had the correct data, you could potentially listen to a phone call, and once it sort of tricks far enough in one direction, send a warning. Do you see some way that that like falls apart?
Pavel, can you start collecting such data?
Good question.
I can do something with that if you do.
Yeah, I think it's doable.
Yeah, that's really interesting. And I think that, again, it would provide possibly some insight. Of course, it needs to be tested. And of course, we need to collect good quality data. But there's always some pattern, right? So, yeah, and since the TF-IDF is able to capture this linguistic signature, it should work. But I am not going to give promises before Pavel collects the data.
Yeah. Yep.
Just a quick question. In the future, do you see threat vectors using this model to beat this model? Using this model to build websites that will beat this model?
This model is our internal one. So for attackers, they don't have access to any indicators or any intermediate output, so they can't tweak the attacks against this. Only indirectly from, I can imagine that they can follow the detection patterns and so on, but it's too hard and too complex, so I strongly doubt. Okay, any other question? Yeah?
Outside of, by the way, great presentation, I enjoyed it. Outside of just collecting credentials, do you see phishing sites also like collecting two-factor authentication codes? So like logins, like Microsoft or something?
Basically, they try to collect everything. Recently I went through a similar phishing page I presented here, and try to fill all those fields using some fake data and monitor what's going on in the background. So there was about 5 steps. So if you fill, for example, your login details, it asks again for your personal details. Then if you fill them, it asks for your credit card details. So they try to juice you for everything what you can get them until the point you realize that you are on the wrong place. So very often phishing toolkits are built in such a way that they try to attract the victim to stay on the page, as long as possible and get basically everything, even not directly connected to the original use case.
And I have a second question. When you identify like a phishing domain, do you collect like any downloadable executable that might be serving malware?
Yeah, in case we identify some other indicators, we use them. So immediately we follow any links which go through this particular website or malicious site. And of course, if there is some download link, we try to check if the binary is available. But here we face problems with scraping because of restrictions on user agent and so on. So it's a bit challenging. But yeah, generally yes.
Yeah, and also one more issue with scraping is that in most of the cases we don't have the full URL. We do not really know what is the relevant page.
Yeah.
When identifying these domains associated with these phishing campaigns, how do you deal with or tag ones that are leveraging legitimate like CDNs as part of their campaigns?
How we are dealing with sites which try to hide behind CDN?
Ones that are using like a legitimate domain that might be used for a number of like ad delivery or other purposes too. But how do you deal with tagging and blocking those, but also kind of
Good question. Yeah, it depends on the service. For example, Firebase, which is frequently used by attackers because it's very easy to set the account and create a page. In this particular case, you get unique domain. So even if the SLD domain is still Firebase, there is a long string you can use for detection because it's unique for the attack. So in this case, it's still some unique domain. But for example, when attackers are trying to use some, for example, Dropbox or other services just serving the content, we can't block the domain. We need to block full URL. And here we hit the issue with visibility that not always we have the full URL, but just domain. So yeah, we still can block URL, but not always we have it. So sometimes it's hard to block it. Okay, any other question? Okay, so thank you very much. And in case